Hello students, now we are going to learn about a flip-flops. So what do you mean by a flip-flops? A flip-flop is an electronic circuit with two stable states that can be used to store a binary data. The stored data can be changed by applying varying inputs. Flip-flops and latches are fundamental building blocks of digital electronic system used in computers, communication, and many other types of system. Flip-flops and latches are used as data storage elements. It is the basic storage element in sequential logic. But first, let's clarify the difference between a latch and a flip-flop. So, the basic difference between a latch and flip-flop is gating or clocking a mechanism. For example, let us talk about SR latch and SR flip-flops. In this circuit, when you set S as active, the output Q would be high and Q complement will be low. This is irrespective of anything else. This is an active low circuit. So active here means low, but for an active high circuit, active would mean a high. A flip-flop on the other hand is synchronous and is also known as gated or clocked SR latch. In this circuit diagram, the output is changed. That is, the stored data is changed. Only when you give an active clock signal. Otherwise, even if the S or R is active, the data will not change. Let's look at the types of flip-flops. Now, SR flip-flop, there are majorly 4 types of flip-flops, with the most common one being SR flip-flop. The simple flip-flop circuit has a set input S and a reset input R. In this circuit, when you set S as active, the output Q would be high and Q complement will be low. Once the outputs are established, the wiring of the circuit is maintained until S or R go high or power is turned off. As shown above, it is the simplest and easiest to understand. The two outputs as shown above are the inverse of each other. Now next is JK flip-flop. Due to the undefined state in the SR flip-flop, another flip-flop is required in electronics. The JK flip-flop is an improvement on the SR flip-flop where S equal to R equal to 1 is not a problem. The input condition of J equal to K is equal to 1 gives an output inverting the output state. However, the outputs are the same when one tests the circuit practically. In simple words, we can say if J and K data input are different, that is low and high, then the output Q takes the value of J at the next clock edge. If J and K are both low, then no change occurs. If J and K are both high at the clock edge, then the output will toggle from one state to another. JK flip-flop can function as set or reset flip-flop. In a D flip-flop, the output can be only changed at the clock edge and the input changes at other times, the output will be unaffected. The change of state of the output is dependent on the rising edge of the clock. The output Q is same as the input and can only change at the rising edge of the clock. A T flip-flop is like J flip-flop. These are basically a single input version of JK flip-flop. This modified form of JK flip-flop is obtained by connecting both inputs J and K together. This flip-flop has only one input along with the clock input. These flip-flops are called T flip-flops because of their ability to complement its state, that is toggle, hence the name toggle flip-flop. So what do you mean by a register? Register is a collection of set of flip-flops used to store a set of bits. For instance, if you want to store an n bit of words, you need n number of flip-flops. A flip-flop can store only one bit of data, that is 0 or 1. A number of flip-flops are used when the number of data bits to be stored. A register is a set of flip-flops used to store a binary data. The data storage capacity of a register is a set of bits of digital data that it can retain. Loading a register can be defined as setting or resetting the separate flip-flops, that is, giving data into the register so the status of the flip-flop communicates to the bits of data to be stored. Data loading may be a serial or parallel. In serial loading, the data is transferred into the register in the form of serial, that is one bit at a time. But in parallel loading, the data is transmitted into the register in the form of parallel form. That means all the flip-flops are activated into their new states at the same time. Parallel input necessitates that the set or reset controls of every flip-flop to be accessible.